Let's start. Till the previous lecture, we were talking about diesel engines, direct injection and indirect injections. We understood the difference between both of them, and we learned that in order to enhance or improve the mixing between the diesel and the air, we can do two things, either from the air side or from the fuel side. From the air side is to increase the swirl as much as possible, which is limited in direct injection engines. Okay, so in direct injection engines, we rely on the fuel. So either increase injection pressure to a very high level up to 3,000 bars, okay, or we can use multi-hole injector to improve the mixing with the dense air. And we couldn't increase the injection as a compression ratio much, okay, because as you increase it higher, you will make the air inside the combustion chamber denser, so it will be harder to penetrate with the fuel, and you will need a higher injection pressure, which is impractical if you increase the pressure over 6,000 bars. Okay, so if we wanted to increase the compression ratio to get more power, okay, we had to move to the indirect injection engines. And in the indirect injection, we add a breathe chamber, okay, before in the cylinder head, where the injection is done in the breathe chamber. And we rely on the orifice between the main chamber and the breathe chamber to create a fast flowing mixture between the air and fuel, where it combusts in the breathe chamber and flows back into the main combustion chamber. Now, and we learned that for the indirect injection diesel engines, we do not need very high injection pressures. Okay. Now we will discuss the fuel system of the diesel engine. What are the objectives of the diesel fuel injection system? We have 5 main objectives. The first one is to meter the correct amount of fuel and distribute it evenly on each cylinder, to inject the fuel at the correct time and at the correct rates. Okay? And to inject the fuel with high pressure enough to atomize the fuel into very fine droplets to allow it to mix well with the air. Okay? And also to begin and end the injection sharply without dribbling or after injection. Okay? Maybe the last part is the one that needs slight explanation. Why do we need to begin and end the injection sharply? Let's give an example with water sprayer, okay, or water sprayer, maybe the perfume bottle, okay. If you press the top of the bottle with soft pressure, okay, what happens to the spray exiting from the bottle? It's like droplets, okay. But what if you press it one time hard? It will be a smooth spray, okay? So, what did you do when you pressed it hard? You started the injection and ended it sharply, okay? If you didn't do it and you pressed it slightly, and you will find that the exiting droplets are of larger size. So they will be harder to evaporate and harder to mix with the air, which will not burn effectively and will maybe unburned fuel will exit with the exhaust and will have very low efficiency. Okay, that's why we need to begin and end the injection sharply. What are the the elements and components of the fuel injection system. For the elements should satisfy the objectives. Okay? So we will need pumping elements to move the fuel from the tank to the cylinder. We will need metering elements to measure the correct amount of fuel. We will need distributing element to distribute the fuel effectively to each cylinder. We will need timing control to adjust the start and end of injection. And we will need a mixing control which will atomize the fuel and distribute it across the combustion chamber. Okay? So what are the components that are required to achieve the objectives? We will need first the fuel tank to store fuel. We will need low pressure pump to transfer the fuel from the tank to the high pressure system. We will need a high pressure pump to generate the very high pressures that we require. And we will need high pressure lines to transfer the high pressure fuel from the pump to the injectors. And we will need the injector, either mechanically or solenoid injector, to atomize the fuel and inject it inside the cylinder. A quick question. If you remember in the steel combustion, okay, there was a similar slide for the gasoline injection system. Okay, we had only how many fuel pumps did we have? Gasoline, one pump. Okay, one pump to transfer the fuel from the tank to the injectors directly. Okay, why did we say in diesel that we need two pumps, low pressure and high pressure pumps?
لو بريشر عشان التانك اللي قدام، بعد كده هاي بريشر عشان الديزل عامة بيحتاج هو يبقى مميز أكتر، هو بيكون يعني بيتضغط، بس أنا الكمبريشر هو اللي بيخليه يعمل كومبشن، فبيحتاج الكمبريشر على ده صح؟
لا، أنت ملخبط ولا أنت كده؟
عشان يحصل ميكسنج أحسن بس في الهاي بريشر عشان يعمل بيتر ميكسنج.
We said that the injection pressure for direct injection diesel engine could reach 3,000 bars, and for the indirect injection we will need lower pressure which could reach 900 or 1,000 bars. Okay. What if I used a single pump to raise the pressure from the atmospheric pressure from the tank to maybe 1,000 or 3,000 bars? Okay. What will be the requirements of this pump?
عشان توصل تستحمل هاي بريشر سواء مسافة بعيدة
No, it's not. مش دايما ايه السبب؟ لا.
هو السؤال فين مثلا؟
ايه؟
السؤال فين؟ مثلا النمبر العالية في
ان انا لو بدل ما استخدم لو بريشر وهاي بريشر بامبس، تمام، استخدمت بامب واحده بس هي اللي ترفع لي من بريشر التانك لحد بريشر الانجكشن العالي. ليه ما بعملش كده؟ It's simple principle. If I used a single pump to raise the pressure, you know how do pumps increase pressure? All pumps have a slight compression ratio. Okay? And it depends on the intake pressure. If the intake pressure is low, okay, for example, the water pumps at home. If the incoming water pressure is very low, can it raise the pressure effectively, or can it raise the water effectively to your home? No, it will be still at lower pressure. But what if the main water pressure is high? how will be the pressure inside the hole? It will be much higher because the initial pressure is higher. So pumps rely on, it's not perfectly correct, but it gives the idea that pumps rely on a specific compression ratio or pressure ratio. Okay? So if I want to raise from 1,000, from 1 bar to 1,000 bars, so the pressure ratio will be 1,000. Okay? But if I raise the pressure from slightly higher pressure, maybe 5 to 1,000, the pressure ratio will be 200 only. Okay? So I will need a simpler and less power consumption from the high pressure pump. Okay? That's why we use two pumps. The low pressure pump raises the pressure from the tank atmospheric to approximately 5 or 6 bars. Okay? And the high pressure pump takes the 5 or 6 bars and raises them to starting from 1,000, 2,000, 3,000 bars according to the injection systems that we have. Okay?
هو السبب الوحيد يعني
إيه؟
يعني البريشر مش السبب الوحيد.
هو ده الاساسي. هو ده الاساسي. ولما هنشوف كمان شويه هتلاقي ان انت البامب يعني انواع من البامبس الهاي بريشر صعب ان هي تسحب الفيول بسهوله او محتاجه سبورتنج سيستم ليها. في انواع ممكن عادي تسحبها، في انواع هيبقى صعب ان هي تسحبها. بس الاساسي هو كله مساله عمليه زي بالظبط انت لما في انتوا خدتوا الجاز ترباينز مثلا. خدتوا جاز ترباينز؟ تمام؟ الجاز ترباين دي مش بتلاقي الكمبريسور اللي فيها مش كذا ستيج ورا بعض. طب ليه انا عملت كذا ستيج وما عملتش ستيج واحده بس؟ لا البريشر هيعلى مره واحده عادي جدا. ما انت الخارج بتاع اول ستيج بيدخل على ثاني ستيج والخارج الثاني ستيج بيدخل على ثالث ستيج وبيعلى بعض عادي. مفيش مشكله. هي تقسيمه للحمل اللي بيتوصل عشان انا الحمل ما بقاش مخليه على كومبريسور واحد بس ان هو يرفع لي البريشر ريشيو دي كلها.
عشان هو يبقى كده
هو كده وانا لو كنت هخلي الثلاثه كومبريسورز دول في كومبريسور واحد تمام هياخد نفس الحجم تقريبا.
بس هيبقى لود كبير بقى الكمبريسور.
هيبقى لود كبير ان انت تشغل كومبريسور واحد من اول الواحد بار لحد
مثلا
زي بالظبط. اقول لك مثال تاني. لو انت جاي عايز تطلع مثلا تشيل طوب تطلعه من تحت من الدور الارضي تحت لحد الدور الرابع هنا اللي احنا فيه. تمام؟ لو انت لوحدك خليتك تطلع الطوب من الارضي للرابع هتفضل تعمل ايه؟ تشيل من الارضي تطلع الرابع تنزل من الارضي تطلع الرابع وهكذا. هيبقى مجهود كبير جدا عليك. انما لو خليتكم انتوا الاثنين بتبدلوا مع بعض انت بتطلع للتاني وهو ياخد من التاني يطلع ايه؟ الرابع. المجهود على كل واحد فيكم هيبقى ايه؟ اقل. فاللود هيبقى اقل عليك. تمام؟ فهي الفكره كلها ان انت بتقسم اللود بدل ما يبقى الحمل على كومبوننت واحد يبقى الحمل على الاثنين. هل الباور اللي انت هتسحبها لوحدك عشان تطلع من الارض للرابع تمام؟ هتبقى هي تقريبا هتبقى الباور اللي انتوا الاثنين هتبقوا ايه؟ تسحبوها. تمام؟ بس انت بص لها فروم ميكانيكال بوينت اوف فيو اور باور بوينت اوف فيو. انا بقى عندي بدل ما جهاز واحد بيسحب باور اكس بقى عندي جهازين اصلا كل واحد منهم بيسحب نص ايه؟ نص اكس. تمام؟ احنا بالنسبه for the low pressure system it's the same for all high pressure injection systems. That we have different high pressure fuel injection systems for the diesel. Inline, distributor, individual injection pumps, unit injector, unit pump, common rail system. All these systems are for the high pressure injection pumps for the diesel engine. What are the main differences between these systems? The difference is in the high pressure generation method, okay, and in the control of start of injection and injection duration. They all perform the same task. They raise the pressure from approximately 5 bars to the injection pressure. Okay? But the main difference is how they generate the high pressure. Okay? The control of fuel quantity and the injection timing can be either done mechanically or electronically. Okay? You will see in these systems how it can be done. So, for this schematic, you have the fuel tank, okay, and you have a filter, coarse filter inside the tank. You have the low pressure pump, which is the supply pump. It supplies the pressure, passes by the filter to the high pressure pump. Okay? From the high pressure pump, you pass through high pressure lines to the injector inside the combustion chamber. If you remember from the theory of combustion for the gasoline system, we explained similar parts like this, slight differences. For the fuel tank, it must be, its function is to store the fuel. It must be corrosion resistant and leak proof. Okay. The gauge pressure, any gauge pressure difference must be relieved. Okay. It is the tank. Inside the tank, there are baffles to make the fuel stable inside the tank and not swing from side to side when taking hard turns. Also, in case of emergencies or if the vehicle is tipped over, okay, or rolled over, the tank must be sealed and not release any fuel from it. Okay. For the low pressure lines, okay, they are made from flexible frame retardant tubes reinforced with braided steel. Okay, because they operate at low pressure, maximum 5 bars or 6 bars. Okay, the fuel lines must be placed. The tank, we all know the tank is at the back of the car. Okay, and the injection system is at the front with the engine. So you need to transfer the fuel from the tank to the front. The fuel lines, these fuel lines must evade or avoid any flat surface under the vehicle. In case the vehicle hits a bump or a rock from the bottom, they shouldn't hit the fuel lines. The fuel lines should pass through special passages inside the bottom of the vehicle. The first difference between gasoline and diesel low pressure system is the fuel filter. In gasoline, we only used small filter, okay, to separate any impurities in the fuel. But with diesel, we always have two-stage filtration. The filter consists of two stages. One stage is to reduce the impurities. Okay? The second stage is to separate the undissolved water from free water to avoid corrosion damage. Diesel fuel itself has the ability to absorb moisture from atmosphere. Okay? This water in very humid places, if it entered the high pressure lines and pump, okay, it will cause corrosion in them and will damage the pumps. So we must separate the water from the diesel fuel. Okay, so that's why in diesel we have two filters. One is a water trap or water separator, and the other is particulate separator. And by the way, diesel, it's known to be a very dirty fuel. Diesel fuel has many impurities in it. Okay? When you go to the lab, okay, ask the engineer Abdurrahman, ask him to show you the impurities in the fuel line in the engine that's in the inner room. Okay? You will see we have transparent fuel lines and diesel tank. You will see a lot of impurities in the line. This diesel fuel, we get it from the fuel station regularly. Okay, the same that goes into the cars. You will find very much, lots of impurities in the diesel fuel. Okay, gasoline doesn't have this much of impurities. As for the fuel supply pump, which is the low pressure pump, its function to deliver the fuel from the tank and pass it through the filter and the water separator till it reaches the high pressure pump. The low pressure pump or supply pump could be mechanically driven or electrically driven. We know the electric fuel supply pump, which is the vane or roller pump types. If it's mechanically, it could be mounted on the engine, okay? Or in some cases, it could be mounted inside the high pressure pump itself. Okay, if the system allows, the low pressure pump will be mounted inside the high pressure pump itself, and we will see later. The mechanical pumps, there are three main types: diaphragm pump, plunger pump, and vane pump. As we will see later, plunger pump, it's mainly used with inline injection pump, and the vane type mainly used with distributor type pump. Okay? As for the electric fuel supply pump, it can be installed either in line or in tank. Okay, some pumps are installed in line, and some are installed inside the tank itself. It operates electrically with an electric motor inside the pump itself. Okay, so whenever you start the vehicle, the pump starts right away. Okay, the pump always draws more fuel than the maximum needed from the injection system. Why? In order to make sure that at any driving condition we have the sufficient amount of fuel that the system needs. Okay? So what happens to the excess fuel that is drawn? It returns back to the tank. Okay? And this excess fuel also helps in cooling the high pressure pump and the fuel system. Because we know the high pressure pump, any fluid that is compressed, what happens to its temperature? Increases. Okay? And the high pressure pumps, where are they installed? They are installed on the engine, very near to the engine. So they suffer from the high heat from the engine. Okay? So the extra fuel drawn by the electric fuel supply pump helps cooling the high pressure pump. Okay? For diesel engines, we might need a third pump. But this third pump is very small one. It's called a priming pump. Do you know what is a priming pump? المفروض خدوها في فلويد يعني.
فاكر البرايمنج اللي احنا عملناه تقريبا بتشيل الهواء
صح، بتشيل هواء ايه بقى؟ كمل.
من البمب او البايب لاين بتشيل الهواء.
صح، الله ينور عليك. كنا بنشيل الهواء من اللاينز او من البمب ليه؟
عشان ما نعملش مشاكل.
صح، الله ينور عليك. فعلا we need to remove air from any fuel or fluid lines. Why? Because any existing air in the fuel lines, especially in high pressure systems, okay, will cause cavitation problems. And we know that air is compressible, while fuel liquids are incompressible. So if air exists in the fuel line, okay, what will happen when you try to increase the pressure? The pump will try to increase the pressure, but when it compresses the fuel or the liquid will just compresses the air bubbles inside the line, and the air bubbles volume will decrease, thus giving more volume for the liquid. So when the liquid's pressure increase, it will not increase. So the system won't operate efficiently. So when do we need to use the priming pump? In case of existence of air in the system. When will the air enter the system? No. صح. ما انت قلت اول حاجه
المينتنس اللي هو
maintenance. That fuel entrance. When you perform any maintenance, like replacing the filters or replacing or repairing the pumps, okay, air will enter through the system. So you will have to prime the system and remove all the existing air from it. Okay? Priming can be performed through two main ways. The first one is by using a mechanical priming pump, which is usually with a lever that you keep pressing, okay, until you remove all the air from the system. Or it can be done by starting the engine many times. When you start the engine, what happens? When you try to start the engine, the supply pump will provide fuel, and the high pressure pump will work with the engine. So they will both supply fuel from the tank throughout the system. When the engine is being cranked, all air will flow with the fuel and will exit from the injectors into the engine, the cylinder. Okay? But this method might work with small air amounts, but if there are large amounts of air inside the fuel lines, this method will be very exhaustive on the engine starter, the battery, and might damage parts of the high pressure lines. Okay? يعني انت من الاخر انت في يعني النظام ده انت عايز تطلع الهواء من السيستم، صح؟ تفضل انت تشغل العربيه مش هتدور لان في هواء موجود في السيستم، تمام؟ بس طول ما انت شغالها انت عمال تعمل ايه؟ الالكتريك فيول بامب شغاله عماله تضخ فيول تمام في السيستم، والهاي بريشر بامب شغاله عماله تضخ تعمل انجكشن المفروض جوه السلندر، تمام؟ بس هي مليانه هواء، ففي كل مره انجكشن عماله تطلع شويه هواء صغيرين ايه؟ جوه السلندر بتفضي الهواء اللي فيها لحد ما السيستم كله يتملى بالفيول. اوكي؟
All diesel engines in light vehicle applications have a priming lever on the lift pump, or a separate priming pump to allow for removing air from the fuel system. This is called bleeding or priming. Air can enter the system during filter replacement or when a fuel line is disconnected. Without a priming facility, the start motor would have to crank the engine over to bleed and prime the system. Excessive use of the starter motor for this purpose would damage it, and it would soon discharge the battery. This diaphragm lift pump has a lever that acts on the diaphragm rocker arm. Moving the priming lever moves the diaphragm down. Releasing the lever allows the diaphragm return spring to force the diaphragm up. The action of the diaphragm and valves during bleeding is the same for normal operation of the pump. Since distributed type injection pumps use an internal vein pump, their fuel supply system incorporates a diaphragm type priming pump, usually located on top of the fuel filter. This filter housing includes a diaphragm type priming pump. The diaphragm is connected to an actuating button and is held in its uppermost position by a diaphragm spring. Reed valves connect the priming pump housing to the filter. Pressing down on the actuating button reduces the volume in the pumping chamber, which forces fuel into the filter element. Releasing the button lets the spring lift the diaphragm, which increases the volume in the pumping chamber. Air pressure in the fuel tank then forces fuel into the pumping chamber. A plunger-type priming pump is often used with plunger lift pumps that are mounted on inline injector pumps. It can also be mounted on top of fuel filter housings for distributor-type injector pump systems. The plunger-type priming pump consists of a plunger and a barrel assembly mounted on the side of the plunger pump or on a filter housing. This plunger priming pump uses the valves of the plunger lift pump to direct fuel flow. Plunger pumps mounted on the top of filter housings contain inlet and outlet check valves. Pulling the primer plunger increases chamber volume, which decreases the pressure in the chamber below that of atmospheric. Fuel in the tank is forced along the fuel lines through the inlet check valve and into the pumping chamber. Pushing the plunger into the barrel decreases the volume in the chamber, which forces fuel out through the outlet check valve. When the priming pump is not in use, the hand knob must be screwed closed. This stops fuel leaking out past the plunger and also stops air leaking into the priming plunger barrel.
فيها مشكلة حضرتك؟ Okay. Now we will start with the first type of inline of high pressure diesel pumps, which is the inline injection pump. I will start directly with a video. This pump, you will see it in the left, okay? You see this exact type in the left, okay? I will let you first watch the video. Okay. You saw many movements inside this pump. How does the inline pump work? You can see that there is a camshaft at the bottom, okay, which rotates and pushes a plunger up and down. This plunger moves up and down according to the camshaft position. It's like those plungers are like regular piston and cylinders. Okay, but they are called here, the piston is called the plunger and the cylinder here is called the barrel. So each cam pushes a plunger inside its barrel. Okay? You see how many cam lobes? 6. 1, 2, 3, 4, 5, 6. Okay? How many plunger and barrel assembly do we have here? 6 also. Okay? And they are pushed up and down, and you see that there are 6 top threads. These are called delivery valves. Okay? The high pressure lines are connected to these delivery valves and go to the injector mounted on the engine. Okay? So, from the shape of this pump, does it have, how many cylinders exist on the engine that this pump serves? 6 cylinders. Okay? 6 cylinders. This pump can operate 6-cylinder engine. Each cylinder has a dedicated plunger and barrel system, okay, that operates at the correct time by the movement of the camshafts. Okay? I need to remember the main functions of the high pressure system. It's to pressurize the fuel, distribute the fuel, each cylinder, and meter the fuel. So, the main 3 functions: pressurization, metering, distribution. Okay? How does the inline pump perform the pressurization part? When the cam shaft pushes the plunger upward, I told you that the plunger and the barrel are similar to the piston and cylinder. Okay? So when the plunger moves up, okay, it pressurizes the fuel. So the movement of the plunger pressurizes the fuel, which performs the first function. So the plunger performs the pressurization part. Okay? What about the distribution? How does this pump distribute the fuel evenly on each cylinder? How does this pump distribute the fuel evenly to the cylinders?
الكامشافت نفسها يعني بتعمل تايمنج صح، بتفتح البريد والدور خلاص صح، يعني الموضوع بيمشي. الكامشافت كده كده كلهم مش نفس البوزيشن، فلو هو بيشتغل مع واحدة الثانية تقفل وبعدين تفتح وتظهر كده
بكل بساطة. هو احنا قلنا دلوقتي بالمنظر ده انا عندي كام بارل وكام بلانشر؟ 6. ده يشغل انجن كام سلندر؟ 6. معنى كده ان الديستريبيوشن بيتعمل ازاي؟ ان كل سلندر ليه بلانجر وبارل بيخدموا عليه. The distribution is performed by the means of the existence of a dedicated plunger and barrel for each cylinder. Okay? Each plunger and barrel sends the fuel to a single cylinder only. Okay? So the distribution is performed by making an equal number of plungers and barrels to the number of cylinders of the engines. Each plunger is dedicated to a single cylinder. Okay? شايفين المنظر هنا اهو انت as the camshaft rotates the plunger is pushed upwards. I need you to focus on this part. Okay? Now, بصوا. Did you see the movement of the plunger inside the barrel? This barrel has a cross section. This part, this barrel, is the same as this part. It's actually solid with a hole in the middle. But in the first one, we have a cross section cut in it. Okay? So, you see the barrel, the outer part is the barrel, and you see the plunger inside moving up and down. Okay? This movement up and down pressurizes the fuel. Okay? And pushes the fuel upward to the delivery valve and to the high pressure lines to the injectors. Okay? Now again, till now, did we mention anything about the metering or controlling the amount of fuel? We just explained the pressurization and the distribution. How can we perform the metering function? If you check it now, check the video. Do you see all these brass components? Okay. I want you to check what will happen next. You see that all these brass components move and rotate all with each other, okay, with the outer lever. This outer lever is connected to the accelerator pedal of the car. Okay, when you press the accelerator pedal, it rotates all the plungers. Okay, and this rotation of the plunger controls the amount of the injected fuel. We will see how it is done. But for now, the rotation of the plunger inside the barrel controls the amount of injected fuel. So before we continue, I always ask this question: what is the function of the plunger in the inline pump? يعمل compression, pressurizes the fuel by moving up and down. The second function is the metering of the fuel. As it rotates around its axis with the accelerator pedal, it controls the amount of injected fuel. Okay, so the function of the plunger in the inline system is pressurization and metering. Okay? And the distribution is performed by making a dedicated plunger for each cylinder. Okay? ركزوا بقى هنا في الحتة دي. Do you see the shape of the plunger? Is it a solid shape? No. It has a helical groove in it. Okay? You see when you press the accelerator pedal, you see what happens. See what happens to the plunger? I want you to think of something. You see this hole in the middle? Okay? First, before we talk about this hole, you see all these spaces inside the inline pump? It's hollow from the inside. It has parts, but it's hollow. And you see all the movements, you see the movement of all the plungers and the camshaft, the springs, everything moves. So, can all these parts be moving without lubrication? No, there must be lubrication. Okay? How do we perform the lubrication inside the inline pump? Do we add a specific oil? The diesel fuel itself, it's an oil, it's like an oil. Okay, if you see diesel fuel or hold up a bottle of diesel fuel, it's like oil. Okay, gasoline is like water, it's very non-viscous, has a very low viscosity. Diesel is like oil, it has very high viscosity. So, the low pressure pump, we said that its function is to supply the pressure as a fuel to the high pressure pump. The low pressure pump fills all the cavities of this high pressure pump. All those cavities are filled with diesel fuel. And the diesel fuel continues to fill. You see this upper passage marked in green, okay? This part is also filled with fuel, okay? And you see these holes, okay? When the plunger moves down, okay, the space inside the plunger in front of this hole is open. So the low pressure fuel fills the plunger, fills the barrel above the plunger. When the plunger moves up, it starts to compress the fuel, thus pressurizing the fuel and give it the very high pressure that is required for the injection. Okay? And you see the rotation of this plunger. You see this? Imagine that the plunger is moving up. Okay, look, I will show you the next video, it will be easier to understand better. عايزكم تركزوا. I want you to concentrate in this video. Concentrate on the plunger movement. خدتوا بالكم من المنظر؟ تاني عايزكم تركزوا كويس جدا في حركة البلانجر واتجاهات الأسهم. What happened here? First, you see that there is an inlet port for the barrel and an exit port. Okay? Both ports exist inside the inline pump. Okay? And both ports, okay, are filled with low pressure fuel from the low pressure pump. Okay? So actually, we can depend only on a single port of those. We might not need both ports. Okay? Because you remember in the previous video, there was a passage here, the green one. Okay? So fuel is here and here at the low pressure, 5 bars. Okay? So we could rely on this port only. When the plunger moves down and opens this port, fuel will enter the plunger as a barrel. And when the extra fuel returns, it will return back from this port again to the casing of the inline pump. But let's watch again. The plunger is at its bottom dead center. Okay? And according to this video, this is the inlet port and this is the exit, the return port. And this is the delivery valve, and the injected fuel moves up like this. Before the plunger starts to move upward, as the left inlet port is open, the low pressure fuel fills the barrel above the plunger. Okay? So, as the piston, the plunger moves upward, right now it closed both the inlet and the return ports. So all the fuel inside the plunger, does it have anywhere to go? Yes. It can go upward and start the injection process, which will happen. Check the arrow directions. Okay, you see that here the delivery valve opened and the fuel is being injected. Okay, I need you to check these parts. The helical shape, now it still closes the return port. It still closes the return port. Any slight upward movement, it will, like this, will open a small passage from up here to the return port. So now, any continued upward motion will push the fuel back through the return port. Okay? So now, is the plunger stroke, is it fixed or variable? No, the actual stroke, the movement of the plunger, is it fixed or variable? Yes, up and down. It's fixed according to the cam laws. Okay? So, if the plunger was a solid plunger, then the injected amount of fuel will always be the same every time. Can this be done? No. No, you can't depend on that. You need to change the fuel according to your speed and to your load and to your requirements. Okay? If every time you will inject the same amount of fuel, you can't operate a system like that. You need to change the injected amount of fuel. So, if the actual stroke of the plunger is fixed, you need to specify a variable effective stroke. Okay, what does it mean? What does effective stroke means? Effective stroke means that we can control part of the fuel above the plunger that can be injected into the cylinder, and another part that can return to the low pressure side. Okay? So the plunger will move all the way up and down, but it will not inject throughout all this stroke. This is what happens with the helix or the helical shape that we have. Here, the plunger moves up and down. You see that? Moves from the bottom dead center to the top dead center in both cases. Okay? But you see, what did he do here? You see, the plunger rotates. What did this rotation do? For this type of plunger, you see that as long as the top of the plunger passes the inlet and return ports, it closes both the return and the inlet ports. Okay? So as it moves up, the fuel has no place to go but through the check valve, the delivery valve, and to the injector. Okay? But as soon as the helix opens the return port, the excess fuel above the plunger can't move upward again. Okay? Because the injection is at very high pressure. Okay? So any fluid, if it has two passages, one with very high resistance and one with a very low resistance, where does it go? Through the lower resistance. And the lower resistance is to go back again to the pump's casing at a 5 bar pressure rather than being injected at 1000 or 2000 bars into the injector. So the remaining of the upward stroke, it pushes the fuel from the top of the plunger back to the casing of the pump. So did the plunger inject all the fuel drawn before it started to move? No, it only injected part of the fuel. So how do we control the amount of injected fuel? You see, if I rotated the plunger like this, when it goes down, the fuel enters and fills the barrel. Okay? And when it goes up again, now it closed both the inlet and the return ports. And it moves up. You see the rotation of the plunger. What did it do? It delayed the opening of the return port. Okay? Again, watch it. تعالى انا عايز هنا ايه؟ احاول اعلم لكم بس مش عارف هنتعلم ازاي. Okay, it will be hard to mark it here, so we'll have to watch it and keep close look. see, when you rotated the plunger, the return amount of fuel got reduced and the injected amount of fuel increased. Okay? Because the rotation of the plunger delayed the opening of the return port. Okay? So you injected more fuel. This is called the effective stroke of the plunger. So each plunger has an actual stroke, which is the movement from the bottom dead center to the top dead center based on the cam's profile. Okay? And the effective stroke, which depends on the rotation of the helix of the plunger and how long does it close the return port. Okay? Now, okay? For now, let's think if we need 2 ports. Let's assume that this port doesn't exist. Okay? So when the plunger is at the bottom dead center, the fuel will enter from this port here to fill the barrel. And when it moves up, it will close the same port, and when the helix opens the return port, the fuel will come back again through this port to fill the pump. So, does the inline pump and the plunger and barrel assembly require 2 ports, inlet and return? No, it can operate with a single port. Okay? So, according to the design, some pumps may have 2 ports, one for the inlet and one for return, and some pumps might have only 1 port for both inlet of fuel and return. You remember the bronze colored part that was like a gear that was around each plunger? This is how it moves. It has a geared back and a rack that moves right and left. So as this rack moves right and left, it rotates the plunger. بصوا هنا الفيديو بيتحرك ببطء جدا. طول ما انت بتطلع كده دلوقتي الريتيرن بورت ماله؟ It's closed. Okay? So as you move up, you inject fuel. But as you see as you opened the return port here, all the fuel starts returning back to the return port. And as you rotate the plunger, you delay the opening of the return port and you inject more fuel. Okay? as you rotate the plunger more, it will keep closing the return port for longer time, thus increasing the injected amount of fuel. Okay. We have three types of plungers. The first one, second, and third. This first one is like the video that we saw. Okay? I need to show you the first video. Can you focus on this plunger? Does it look like the plunger of the video, the previous video? No. The previous video, it was solid from the top and the helix goes down. This plunger is hollow from the top and the helix starts down, okay? Like this part. This is the first plunger. This is the second plunger that similar to the plunger of the pump that is in the lab. Okay? For the first one, the helix, the helix is solid at the top, and it decreases from its cross-sectional area, decreases as it goes down. For the second type, the helix is hollow from the top, and it increases as it goes down. The third type, it has both types, helix, hollow from the top and goes down, and another helix from the middle to the end of the plunger. So the first plunger is solid at the top and the helix moves down. The second plunger is solid at the bottom and the helix moves up. Okay? The third type, it has a helix from the top and another helix from the bottom. How do they all differ in performance? No, the metering of all of them will be the same. Will be the same. You will only control the start and end of the injection. The three helixes will give you the same metered amount and will give you the same pressure. But I want you to imagine if the three helixes starting to move up. They are moving all up at the same time and at the same level. Which one will close the return port first? The first one will close the return port first. When it closes the return port, what will start? The injection. So the first helix will be the first one to start the injection. The second and third will be still returning fuel to the return port. Okay? Which one of them will first? So this helix 1 will start the injection first. Which one will start the injection second? 3. And the third one which will start the injection 2. As they move, the three of them go up, which one will end the injection first? Will end. One will end the injection first. Then 2, then 3, then 2 will be the last one to end the injection. So the 3 of them will give the same amount of fuel, but they will give different injection start and end times. Okay? So the first plunger always begins the injection at the same time, but according to its rotation, it will end the injection at different times. So you control from the first plunger, you control the end of injection time. The second plunger, you control the start of injection according to the rotation of the helix, but the end of injection will always be the same because the end is flat. Okay? The third plunger, according to its rotation, you will control both the start and end of injections according to its rotation. So the question now, can you replace the plunger from 1 to 2 or 3 for the same engine and the same pump? If it will give you the same amount of fuel and the same pressure? No, you can't. Why? Because every engine is calibrated and adjusted for a specific start or end of time or end times of injection. Okay? So if you replaced the plunger 1 with 2, the engine that uses plunger 1 is calibrated that always the start of injection is constant and you only control the end of injection. If you replace plunger 2 and put it in its place, the injection timing will change. You will vary the start of injection and will have a fixed end of injection, which will give bad operation to the engine. Okay, so these 3 shapes of barrels aren't interchangeable. You can't replace them for the same engine. If you replace the barrel shape, the plunger shape, you will have to recalibrate the engine. Okay, because changing any shape from those will change either the start or the end or both start and end of injection. Okay?
Can we have them in one engine? 3 of them?
No. All plungers in the pump will have the same shape. All plungers will have the same shape.